prove that 2 times 7 to the power n plus 3 times 5 to the power n minus 5 is divisible by 24 for all n belongs to n, where n is a natural number. So we'll start with the statement. Let P of n is equal to 2 times 7 to the power n plus 3 times 5 to the power n minus 5 be divisible by 24. So we are accepting the statement be divisible by 24. Okay, so now to accept, to test this, let's take P of 1. Let's take P of 1, where 1 is the first natural number. So this is 2 times 7 to the power 1 plus 3 times 5 to the power 1 minus 5. So this is 14 plus 15. So this is 14 plus 15 minus 5. So this is 29 minus 5, which is 24. So we can say P of 1 is true. P of 1 is true. So P of 2, so this is how we prove by mathematical induction. So we'll take P of 1, and that's true. And we'll say let P of m is equal to 2 times 7 to the power m plus 3 times 5 to the power m minus 5 be true. If that is true, and then if we can prove P of m plus 1 is true, then here we are accepting this to be true. And for P of m plus 1, we're going to prove that to be true. If P of m plus 1 is true, P of m would be true. Okay, so P of m plus 1 would become, okay, now before that, we need to do one simplification. Okay, so can we write, this implies P of m is 2 times 7 to the power m plus 3m, 3 times 5 to the power m minus 5 is equal to 24 lambda. So we are saying, because if this is true, if this is divisible by true, if this is true, means this expression is divisible by 24, and that's why I equated that equal to 24 lambda. So now if I make 24 3 times 5 to the power m as the subject, can I say 3 times 5 to the power m would be 24 lambda, 24 lambda plus 5 minus 2 times 7 to the power m. Okay, so let me repeat myself. There's nothing wrong in repeating. So what I'm saying is, when you say that P of m is true, what are we saying is P of m is divisible by 24. And if P of m is divisible by 24, that expression P of m is a multiple of 24, and that's why I wrote 24 lambda, where of course I should write lambda. Lambda is a natural number. Lambda belongs to n, which is natural numbers. Okay, so can we say, now what is P of m plus 1? This is the main proof. So P of m plus 1, if this is P of m, is 2 times 7 to the power m plus 3 times 5 to the power m minus 5. So P of m plus 1 would be the same thing, but in place of m, you're going to replace it by m plus 1. So this is 2. This is 2 times 7 to the power m plus 1 plus 3 times 5 to the power m plus 1 minus 5. Okay, so this is equal to, I can write this as, I'm not going to change this. I am writing this as it is, but here I'm going to make a slight change. This is 3 times 5 to the power m times 5 take away 5, or 5 to the power 1. So I'm using the exponent rule. So this I'm expanding. 5 to the power m plus 1 is same as 5 to the power m times 5 to the m times 5 to the power 1. Now we know 3 times 5 to the power m is something, which is 24 lambda plus 5 minus 2 times 7 to the power m. So that becomes 2 times 7 to the power m plus 1, plus, in place I'll write 5 first up front, times, this is 24 lambda plus 5 minus 2 times 7 to the power m minus 5. This is a bit of algebra. You have to be patient. So 2 times 7 to the power m plus 1. Now let me expand this. This is 120 lambda plus 25 minus 10 times 7 to the power m minus 5. Okay, let me scroll up. So this is equal to, I'm expanding this further. So this, can I write, this is 2 times 7 to the power m times 7 to the power 1 minus 10 times 7 to the power m plus 120 lambda plus 20. 25 minus 5 is 20. And this I have written as this. 7 to the power m plus 1 is 7 to the power m times 7 to the power 1. So this simplifies to 14 times 7 to the power m minus 10 times 7 to the power m plus 120 lambda. This is 120 lambda. Let me write this properly. 120 lambda, 120 lambda plus 20. This 20 I'm going to write as 24 minus 4. Okay, this is something, a tricky step. So what can we factorize? What can we factor out here? We are going to factorize something out from there. So let me change color. So this is equal to, what can you factor out? You can factor out 7 to the power m. You have 14 minus 10 inside the bracket. I'm writing this minus 4 after this. Plus, if you factor out 24, this is 5 lambda plus 1. This is 14 minus 10 is 4. So this is 7 to the power m times 4 minus 4 times 1 plus 24 times 5 lambda plus 1. Okay, we're almost there. So this is equal to, I can factor out the 4 here. From this, what can we factor out? You can factor out a 4. So if you factor out a 4, you have 7 to the power m minus 1 plus 24 times 5 lambda plus 1. Now this is, of course, you can prove it yourself. This is always a multiple of, let me give you some example. Suppose m is 1. I think I should have written m should be 1. M is a natural number. Okay. Yeah. So here m, I should have written m belongs to n. M belongs to n. So let me scroll up. Okay, so this is equal to 4 times. This is a multiple of, this is a multiple of 6. I wanted to give you some example. If m is 1, 7 to the power 1 minus 1 is 6. 6 is a multiple of 6. If you do 7 to the power 2, 7 squared minus 1. This is 49 minus 1, which is 48. 48 is a multiple of 6. 7 cube. So let me use a calculator. I don't know whether I can bring my calculator up. 7 to the power 3 minus 1 is 242. So let me bring this down. Let me bring it. Okay, so let me show you. 7 cube, menu run. 7 cube minus 1 equal 342 divided by 6. That's exactly divisible by 7. Okay, so yeah, so this is 343, and 343 is divisible by 6. So this is going to be a multiple of 6. So this you can write as 6 times mu. Okay, where mu, I'm writing it here, mu also belongs to n. Okay, that means what we are saying is this is a multiple of 6 plus 24 times phi lambda plus 1. So this is 24 lambda, 24 mu plus 24 times phi lambda plus 1. And if you factor out 24, mu plus phi lambda plus 1. Now mu is a natural number. Mu is a natural number. Lambda is also a natural number. Phi times a natural number plus a natural number plus 1. This is going to be a natural number. So this is 24. So this implies P of m plus 1 is divisible by 24. Is divisible by 24. So we can say P of m plus 1 is true. Okay, this implies P of m plus 1 is true. We have proved this, which implies P of m is also true. Initially we accepted to be true, and now if P of m plus 1 is true, P of m has to be true. So this implies we can say 2 times 7 to the power n plus 3 times 5 to the power n minus 5 is divisible by 24. Is divisible by 24.